All right, so the second part of this week's lecture deals with content analysis. And content analysis is a systematic procedure devised to examine the content of recorded information in an objective and quantitative manner. So, content analysis basically deals with any type of analysis that is done to already existing content that is out there, that is archived, that we document in a certain way. And the whole point of content analysis from a quantitative perspective is that there's a systematic way for analyzing the content. People who follow the content analysis method argue that it is objective because there are set coding schemes that operationalize the major concepts, and independent coders can actually code the data in an objective way. And it's quantitative. It is different from other forms of qualitative content analyses because we're assigning numbers to actual concepts, to actual instances of concepts or certain definitions. So we use content analysis to describe communication content. They're such as content analyzing newspapers, television programs, ads, PR, press releases, anything that you can think of, any type of content can be analyzed through content analysis. We can also test hypotheses about message characteristics and features. So an example of that is conducting a content analysis study about the portrayal of what types of messages are shared on YouTube that deal with smoking cessation or electronic cigarettes. So we're trying to figure out what are the characteristics of existing messages. The third type is assessing how media reflect or portray reality. And there have been numerous studies on the portrayal of women, on the portrayal of minorities and ethnic groups in media. But all in all, content analysis can stand on its own as a research method. It is also good for starting new research projects. So for example, if we were to do a project about certain message features in public service announcements, in order to get what these features are, a content analysis of a random sample of the messages of public service announcements can be analyzed, and therefore we can figure out what are the most prevalent features that are there to use them in an experiment later on or in a survey. So it can be a starting point to other research projects. Its limitations, I'll start with them before going on how to do it, because it's important to acknowledge that this method, as well as every other method, has certain limitations. One of the major problems that in interpreting content analysis results is when researchers claim that they have explained causality, the effects of media, by looking at content. Of course, this is not possible because content analysis does not tell us anything about causality. It just tells us what's there and what's not there, so it's highly descriptive. Results are limited to the study itself because researchers operationalize categories and concepts in different ways. So sometimes there's a limitation that there is an element, and this relates to the last point. There is an element of subjective decision making that takes place when conducting a content analysis study. The two other factors are not so related, but the first one deals with the fact that it is limited by whatever is on the media, whatever is covered by media. So we cannot explore anything beyond that. And the other problem with content analysis is that it is time consuming and it could be expensive if there's a large sample and you need more coders. So it's highly time consuming. I've only conducted one content analysis study in my life, and I remember that it was very time consuming. Last but not least is there are some arguments that content analysis is actually qualitative and not quantitative. For the reason that I mentioned earlier is that there is so much subjective decision making taking place along the process. But a good content analysis that is done in an objective manner, I think, is quantitative. But there are arguments on both sides. So here are the steps of the content analysis, of conducting a content analysis study. And I won't read them. You can read them on the screen or by opening your book. But what I'll do is I'll try to run through some hypothetical studies that I'd be probably interested in, or some of you might be interested in, and trying to apply these steps into questions that could be answered by content analysis. So, take the first 4 steps: formulating a research question, defining the universe and picking a sample, and selecting and defining the unit of analysis. So, what I want to say about research questions is that the type of research questions that content analysis can answer are different from the ones that surveys could answer, and are totally different from the ones that experiments could answer. So here we're asking about whether certain features, certain characteristics, whether certain groups are present or not present in media. So we're describing media content and putting a quantitative element to it. So I'll be talking about a study that has 2 research questions. The first one, so we're interested in how celebrities manage their online profiles on popular social networking sites. So what we're interested in is figuring out whether celebrities have presence on Facebook or not, and how many followers do the top celebrities have on Facebook. So the universe for our study is, in fact, we need to set a parameter for selecting what the sampling frame is. What is the overall, the population is that we are going to select a sample from. So the universe in content analysis is similar to the population when we're dealing with sampling, and we do sample content in content analysis. So a good way to get a list of the top celebrities is the Forbes 100 celebrities. And since it has only 100 celebrities, then the sample could be census. But also, if, for example, you have a large sample of news articles or TV ads or TV reports, any type of a large sample of content, you can also systematically select a smaller subset of the universe and analyze that. And usually, random sampling techniques are conducted. There are different ways to do it. You either can do systematic random sampling by just picking the 10th story or the 10th video or the 10th advertisement. Or also it could be a simple random where you just put everything in a hat and pick whatever number you'd like. Another thing that content analysis researchers do, and specifically in relation to media content that is time specific. And what I mean by that is when we're talking about newspapers that are published on a daily basis, or media reports that are broadcasted on a daily basis. The most popular technique is to pick a sample, what is called a constructed week sample or a constructed 2-week sample. And the way that this is done, they pick about 3 or 4 months of the coverage, and they randomly pick for the first week that is included in the universe. They pick the Monday from newspapers. Then Tuesday is picked for a different newspaper. Then Wednesday is picked for another. So they construct a week by dispersing the sample into a larger time frame rather than limiting it to 1 or 2 weeks. So pick more than 1 week, like a month or so or more, and then pick a constructed sample from them. So in this research, the unit of analysis is celebrity and the number of followers. And the unit of analysis is the category that we are going to be analyzing. In this case, it's easy because our research is showing, our research questions are really telling us what the unit of analysis is. But it gets sometimes a little tricky with other forms of media. So for example, in newspaper research, the unit of analysis could be the headline, or the lead, or the whole article, or the sentence. It could be anywhere that you, as a researcher, decide on what exactly are you going to focus on and build your content analysis on. And then we construct categories. So for each, and categories are a reflection of the concepts and operational definitions that we have taken either from past theories or we're doing an exploratory study. So in this case, for research question 1, the category is Facebook account. And for the second research question, it is followers, the number of followers. In other, let's say, newspaper research, the categories can be, for example, one of the major theories in our field, the agenda setting theory, relies heavily on content analysis. And the attributes of the news coverage could be the categories of analysis. So whether something is positive or negative or neutral, or whether there are cognitive attributes that are presented in media. So categories can be anything that you derive from past research. The second step, the following step, deals with establishing a quantification system, and this is usually done by establishing a code book. Code books are found in two places. The first place is a code book as a form that explains and defines every single category to the coders. And the other side of the code book is the data entry code book, or coding the data, where you translate the code book into columns where the coders can actually input the data. So in this case, we have decided that for the Facebook account, the first research question, if a celebrity has a Facebook account, then we would mark that as a 1. If they don't have a Facebook account, then we would mark that as 0. The number of followers, we decided to leave it as open-ended. We're gonna write it in. Again, with regards to the coding scheme, because this is the most important part in content analysis, it really explains to the coders what they really need to do, how they define the concepts, how to decide between one category and the other. And as I mentioned, it's a written document, and the reason why we have a code book is to guide coders on the coding process. And the reason why we have coders, and I know one of the questions that I will also get to later on, talked about why wouldn't the researchers themselves do the coding. And it is always favored that independent coders, meaning people who are not the researchers, carry out the coding of content, because it gives more confidence in the sense that the categories that were defined in a good way, other people could understand them, and the fact that it decreases the bias of the research. Coders should be trained, so if you're going to conduct a content analysis, then you need to sit with your coders and make sure they understand what the coding scheme is. And another thing that we need to be aware of is when conducting a content analysis, although many researchers, calculate intercoder reliability post-fact, meaning after the content analysis is done, it is highly preferred that intercoder reliability, how the percentage of agreement or the proportion of agreement between the coders, whether they understand each other, everything is clear, should be conducted at the forefront in the training period. So as if there's something wrong with the coding scheme, that it'll be fixed and the coders won't fall into a state of a gap in their understanding of the coding scheme. So we have coders. In some cases, one person can do the majority of the coding, but in all cases, it is required that at least two people code a minimum amount of the data of the cases, so as to ensure the reliability of the coding scheme. Usually they pick 10 to 15% of the content that two people can code. So let me explain a little bit about this. You can have multiple coders, 1 or 2 or 3 or 4 or 5, and they can divide. So if let's say you have a sample of 1,000 news stories that you would like to content analyze, you can split them among the 4 coders so that each person gets 250 news stories. Before they code them independently, a random sample of your sample, about 10 to 15%, so about 100 stories or a considerable number, will be the same. This random sample of your sample will be coded by all of the coders, and this is how you calculate intercoder reliability. So I'll talk about 2 formulas for calculating intercoder reliability because they're the most often used, even though they're the most liberal and sometimes frowned upon, but they're the easiest also to compute. Holsti's formula is usually calculated for each coding category, and for each after you get all of the reliabilities, you average them, and you give the readers the range of intercoder reliability. So the formula is pretty easy. 2m divided by n1 plus n2. M is the number of cases that the coders have agreed on, and N1 and N2. N1 is what the coders have, what the first coder, the number of cases that the first coder coded, and the number of cases that the second coder coded. So let's say there are 2 coders who coded 10 of the 100 celebrities that we've had in our example. So coder 1 coded 10 cases, and coder 2 coded the same 10 cases. And we have these different categories. So we coded whether the person has an account or not, the number of followers, the number of posts, the number of interactions, and the date joined. And we have we've looked at the data, and we figured out that for the first category, the Facebook account, they agreed 10 times. So perfect agreement there. The number of followers, they agreed 8, number of posts 7, number of interactions 4, and the date joined 9. So we calculate the reliability in this way, and we get these results for the reliability. And the way that we report them, we say that the mean reliability was around 0.76, and the range was from 0.4 to 1.0. So when I see this as a researcher, and I look at the fact that the number of interactions was very low, they didn't agree more than half of the times, then this should be an alarm for me to say, well, there's a problem here. Maybe I should refine the coding category, explain it better, talk to the coders, um, make sure they understand what it is, how to exactly calculate it, or how to code it. Other questions: is there any problem with entering the data? So we now move on to Scotch Pie, which is by far the most popular formula used to calculate reliability, and simply because it does not only include an expression of the amount of agreement, but also the observed agreement, which is relatively the same as the percent agreement that we talked about in the previous example, but the expected agreement. How much do we expect them to agree relative to their own answers? So we're not only looking at where they agree, but also where they do not agree, and how do we expect them to agree. So the formula is the percent observed agreement minus the percent expected agreement divided by 1 minus the percent of expected agreement. So let's take this example. So this is the raw data for coder A and coder B for these 10 different categories, right? And here it shows that we have 3 answers that they can have for this category. They can either code something as a 0, or something as a 1, or something as a 2, as you can see. And as you can see from just visually observing the data, we can see that there are cases where they agree. So the first 5 or so cases they agree, but then the rest not so much. There's a little disagreement there. So the first thing that we need to do is transform this into a table of categories and marginal totals. And here, as you can see, we have it's a diagonal table, meaning that there are certain things that are shared diagonally between the two coders. And so we have coder A and coder B, and we have the categories as rows and columns. So the diagonal categories is this one. It is actually the number of cases that they have actually coded the same. They have actually agreed upon. So here we have 4 for category 0, 3 for category 1, and 2 for category 2. And if we go back to this example, we can see that they have agreed 4 times when they picked 0. So the first 2, and then there's the 4th one, and the one before last right at the bottom right there. We also coded for category number 1. There were 3 cases that they had agreed on, which are the 3rd case, 6th case, and the last case. And also there were 2 times where they have agreed on 2. And the rest of the matrix is computed by the cases where coder 1 coded 1 as 1, where it was coded by coder B as 0. And this is the only time that they have disagreed. So if we were using the Holsti's formula here, the agreement would be 0.9. The reliability would be 0.9. But it does not regard the case in which they did not agree. How was this case evaluated? So, to calculate the observed agreement, we actually sum the diagonal column, this one, and divide it by number of cases. So it's pretty similar to the Holsti's formula. It will yield the same result. If we were doing a Holsti's formula, we would multiply 9 by 2 and divide it by 10 plus 10, so it will give a 0.90 reliability, which is relatively high. However, this is the percent agreement, the percent observed agreement, right? So to calculate the percent expected agreement, what we would do is we go back to this table and we take the marginal totals for coder A and the marginal totals for coder B. The marginal totals for coder A are the very last column on the right side, and the marginal totals for coder B are the very last row. So if you can see here, we'll have to go through the visual effects here. We input them based on the category, and we sum them. And after we sum them, we divide them by the total number of cases that they have both coded. So in terms of 0, coder A recorded 5 zeros, whereas coder B recorded 4 times 0. So we sum that up and divided by 20, the same for category 1 and the same for category 2. And the percent of expected agreement, what we do is we take these joint marginal proportions and we square them and sum them. So the percent of expected agreement here comes up to a 0.365. Try to do the calculations yourself as well. And so in looking at Scott's pie, we are subtracting expected agreement from observed agreement and then dividing it by 1 minus the percentage expected agreement. So our Scott's pie reliability comes to 0.843, which is lower than what we would get with Holsti's formula, which would be 0.90. So this is a bit more conservative compared to Holsti's formula. So the question is that, how to assess if the reliability is good or not. And this is something that is done rather subjectively, somewhat in a, there are standards, but they're not agreed upon standards. The rule of thumb is if the intercoder reliability is 0.50 or lower, then it's really bad. Anything above 0.7 is okay. The closer the intercoder reliability is to 1, the better.